So now we're gonna look at inspiration and expiration, right? So inspire is to breathe in, and then expire is to breathe out, going out, right? So, and we're gonna compare the actual mechanism, what happens, what changes in pressures and volumes, and also the different muscles that are involved. So before we get into that, I wanna talk about 3 different pressures that we're looking at. So what does this look like? This looks like probably, I don't know, what does it look like? A Pope's crown or something like that, or some kind of helmet. This is basically showing you the lungs and what's happening in the thoracic cavity, right? So in the pink, this is your lungs. The green around it, this is referring to as the pleura, okay? Pleura and the pleural cavity, all right? So there's 3 types of pressures that I want you to worry about. So the first pressure is called the pressure, the intrapleural pressure. So this is referring to the pressure in the pleura. This pressure gradient is always negative. Right? It's constantly changing, but it always has a negative value. You have another pressure, intrapulmonary or alveolar pressure. Alveolar pressure is always positive. Okay? This criteria, alveolar pressure is always greater than interpleural pressure. If this phenomena is broken, right? So something happens where they become equal. This is when you have instances of pneumothorax, when your lungs collapse, right? So this is a very bad phenomenon. So this criteria must always be in taking place unless you have some kind of abnormality in your respiratory system. And then finally, you have the transpulmonary pressure. So transpulmonary pressure is the difference between the alveoli, pressure in the alveoli, subtracted by the pressure in the pleura, right? And so this gives you a value, right, in terms of the changes in pressure differences. All right, now let's look at inspiration, right? So inspiration and expiration, they're all a completely passive process, right? Meaning they don't really necessarily require energy, right? And so they begin when there's an action potential that is generated by the phrenic nerve, which leads to the contraction of the diaphragm. So your diaphragm contracts. So the diaphragm contracts, and this contraction leads to the increase of the volume in the intrapleural volume, right? So you have an increase in volume, right? So the thoracic cavity becomes a little bigger, right? So this leads to an increase in volume. So according to Boyle's law, when they correlate volume and pressure, when volume goes up, pressure must go down. So the intrapleural pressure actually decreases, right? This decrease in pressure, according to this equation now, leads to an increase in transpulmonary pressure, okay? Transpulmonary pressure then eventually leads to the increased volume in the alveoli, right? So the alveolar volume begins to increase. You have an increase in alveolar volume, which then eventually leads to decrease pressure, again, according to Boyle's law, in the alveoli, right? So this process here is a very passive process. Now, because the pressure becomes very low in the lungs in relative to the atmosphere, right? So the partial pressure outside is about 760. This pressure becomes a little bit less, a little bit much more less. And because of this decrease in partial pressure of gas, oxygen passively comes into the body, right? So passively comes in to the body, and what's important is the muscles that are really involved, right? So the muscles that are involved here, when we're looking about the inspiration, is mainly the diaphragm contraction. Diaphragm contracts. Your external intercostal muscles, right? So what's a intercostal muscle? So intercostal muscle is your ribs. So the muscle in between your ribs. Okay? And so during normal breathing, these muscles become contracted. All right? Now, whenever it's instances of forced inspiration, you hyperventilate. You begin to inhale very, very rapidly, very, very rapidly. there's two other muscles that become involved during forced inspiration. One is the scalene muscles, and then the other is the sternocleidomastoid. So we could put that here, sternomastoid. Right? These two muscles in pink become only active during forced inspiration. Right? And so expiration is the complete opposite of inspiration in terms of this different regulations. Right? And so when we look at expiration, the phrenic nerve does not generate the action potential, so it's inhibited. Right? So the diaphragm then in turn relaxes. So this relaxation leads to the thoracic cavity to come down, so it leads to decrease volume in the pleura, which eventually leads to the increase in pressure, the intrapleural pressure, which eventually leads to decrease transpulmonary pressure, right, when we look at the comparisons. Then we have, again, a decrease in volume in the alveoli, and then finally an increase in pulmonary alveoli. In the interpulmonary pressure increases, or the alveolar pressure increases, right? And so this, again, it's inverse of inspiration, right? When you exhale, right? So it's, again, another passive process. The muscles that are involved, again, are the diaphragm. So if I were to redraw the diaphragm here, so the diaphragm is involved. What other muscles? So the diaphragm, let me draw this in what color we got here? We got blue. Let's draw it in blue. So the diaphragm is involved, and this is only through a relaxed state, right? Also, what allows for this actually to happen is the internal intercostal muscles. They begin to contract. So now when we're looking at actually during forced expiration, the main muscles that are involved, the intercostals, internal intercostal muscles, and also during extremely forced conditions, the abdominal muscles. So your obliques, abdominal muscles, all are involved during forced inspiration. Okay? And so this is just showing you a basic pathway of how inspiration works and how everything is closely really regulated based off of this. And so inspiration and expiration, remember, it's really important. It's a very passive process, right? So meaning no energy is required, just going from high concentration or high partial pressure to a low partial pressure.